Hello everyone, welcome to my YouTube channel. If you are new, then welcome to my channel. I am Mr. Devi. In this video, we are going to learn CBSE Class 10 Chapter 1 Real Numbers. So without wasting time, let us learn 20 most important questions that's been asked in past few years. So the first question, the sum of exponents of prime factors in the prime factorization of 196. So we need to determine the prime factorization of 196. So 196, if I divide with 2, I'll get 196 divided by 2, which is 98. If I'll divide 98 with 2, that will be 49. And then 7 times 7 is 49. So I'll get 7, 1. So therefore, our 196, which is the prime factorization, which is 2 multiplied with 2, which is multiplied with 7 and 7. So this I'll write it in the exponents form. So that will be 2 to the power of 2. So 7 to the power of 2. So now in the question, it's clearly mentioned that we need to determine the sum of the exponents. So basically, what is sum of exponents? So sum of exponent is something we need to add their powers. So to add their powers, what we have? So 2 plus 2, which is 4. So therefore, our option for this particular answer is option B. So therefore, we can choose option B is the correct answer for this particular question. So next we have second question. The total number of factors of prime number is. So we know as per the definition of prime number. So what is a prime number? Prime number is the number which has 1 and itself is the factors, right? So we know that the prime numbers will have, if I take an examples of the prime number 2, 3, 5, 7, 11. So if I take the 2, what are the factors of 2? 1 and itself. If I take the factor of 3, 1 and itself. If I take the factor of 5, 1 and itself. So therefore, we can say that the prime numbers which has a total number of factors which is only 2. So therefore, our answer for this question is option B, which is 2. Yes. So let us look the next question. So question number 3, the HCF and the LCM of 12, 21, and 15 respectively are. So we need to determine the HCF and LCM. So for the first, to determine HCF and LCM, so we need to determine the prime factorization of the given numbers. So what are the prime factorization of the numbers which are 12? 12 is, if I divide 12 with 2, I'll get 6. 2. 6 divided with 2, which is 3. So I'll get the prime factorization of 12, which is 2 multiplied with 2 multiplied with 3, which is equivalent to 2 to the power of 2 and multiplied with 3. So now I have to do the factorization of 21. So what are my prime factorization of 21? So 7, if I'll take, so 7 times, okay, if I'll take 3, so 3 times 7 and so 7, right? So 7 times 1 is 7. So therefore, my prime factorization of 21, which is equivalent to 3 multiplied with 7. So therefore, I can write here 3 multiplied with 7. So next we have our prime factorization of the next number, which is 15. So if I'll do the prime factorization of 15, which is 3. So 3 times 5 is 15. So 5 times 1 is 5. So therefore, our prime factorization for the number, which is 15, is equivalent to 3 times 5. So which is equivalent to 3 times 5. So now if I want to determine the HCF, so HCF is something which is common in all the three. So we can see the common in all three is only 3. So we can finalize that HCF is 3, and then we have to see the least power as well. So now for the LCM, so we have our LCM which will be equivalent to the highest power of each number. So if we see the common in all the three, if it is even no common, so we have to see the highest power. So the highest power of 2 is 2 to the power of 2. The highest power of 3 is 3 to the power of 1. And then we have 5 and then multiplied with 7. So if you do all the multiplications, so 4 3s are 12, 12 5s are 60, so 60 times 7, which is 420. So therefore our HCF is 3 and LCM is 420. So this is our HCF, which is 3, and our LCM is 420. So therefore our option is here, it is 3 and 420, which is option C. Therefore our correct option is C. So let's look at the question number 4. So the question number 4 says that the decimal representation of 11 by 2 to the power of 3 multiplied by 5. So the option A, terminate after 1 decimal place, terminate after 2 decimal place, terminate after 3 decimal place, and no terminate. So basically to do this question, so we have to write the given expression. What is the given representation? 11 divided by 2 to the power of 5. So to do this question, so we knew that a fraction, which is, I can write this in the form of p to the power of 2 to the power of m and 5 to the power of n. And then we can see that the terminates the after maximum m and n. Okay, so we have to determine whichever we have maximum m comma n. So here we can see which is the maximum. Here we can see that 2 to the power m is maximum. So here the m value is 3 and n value is 1. So we have to see which is the maximum among these two values m and n. So that will be our terminating decimal. So here we can see that m value is 3. So therefore our answer will be C, that will be terminates after 3 decimal. Okay. So terminates after 3 decimals. So therefore our option is C. So I have similar question for question number 5. So you can pause the video and try to do this question. So it's almost similar to this question. So you have to see the denominator whichever the number which has the highest power. Okay, so here 2 to the power 3 is the highest power. So you have to look something like that in the question number 5 as well. So here the decimal place says, okay, so what is the given expression? 2 to the power of 5 and 5 to the power of 2. So now think about the answer. Okay, so now let's do this question. So here we can see that at the denominator, which has the highest power, which is 5 is the highest power for the 2. Okay, so any number, it doesn't matter. So whichever number which has the highest power. So here we can say that the 5 is the highest power. So 5 is the highest power in the denominator. Therefore, 5 is the terminating. Okay, 5 is terminate terminating terminates after decimal place. Okay, so that's what your answer should be. Okay, so I hope you have understood, right? So next question. So the LCM of the smallest two-digit composite number and then the smallest composite number. So what is the smallest two-digit composite number? We have smallest two-digit composite numbers. So if you don't have an idea about composite numbers, so the one which are not prime numbers are composite numbers. So the prime numbers are 2, 3, 5, 7, 11. These are the prime numbers 2, 3, 5, 7, 11. Okay, are the prime numbers within 10. Okay, so we can see the other than prime numbers are called composite numbers. So here, what are composite numbers now? These are prime numbers. Prime numbers are the number which is has only two one end itself is the factor, right? So now if I take 2, it has a 3 factors, 1, 2, and 4 itself, right? So therefore these comes under composite number. So composite numbers are for 1 to 10, 4, 6, 8, 9, 10, all these are composite numbers. So what is the smallest two-digit composite number, which is 10? And then the smallest composite number. So which is the smallest composite number? Smallest composite number. So which is the smallest composite number? Which is 4. You can see here, right? So now we have to determine the LCM between 10 and 4. So we have to find the prime factors of 10. So what is the prime factor of 10? 2, 5, 5, 1. So the prime factor of 10, which is 2 times 5. So what is the prime factor of 4? So 2, 2, 2, 1. So that will be 2 to the power of 2. So now we have to determine the LCM of both. So what is the highest power among these two, which will be 2 to the power of 2 and then 5. So that will be 4 times 5, which is equivalent to 20. So therefore, our option, which is C, which is 20, is the correct answer for this particular question. So I hope you have understood this. Yep. So next question. So HCF of two number is 27. Okay, so it's given that HCF of two numbers, which is 27. And then LCM is 162. So one of the number, which if I'll take the two number, which are the first number, if I'll take it as X, and then the other number, if I'll take it as Y, so then we have to determine the second number. Basically, the first number, I'll take it as X, and then the second number, we have to determine it. So we know that the relation between HCF and LCM, which is X multiplied with Y, which is equivalent to LCM multiplied with HCF. Basically, the first number multiplied with the second number, which is equal to LCM multiplied with HCF. So we know our first number, which is 54, and then the second number, which is I have taken it as Y. And then what is our LCM? So LCM is 162 multiplied with HCF is 27. So therefore, our Y would become, so 162 multiplied with 27 divided with 54. So we know that 162 divided with 54 will give me 3. And then 27 multiplied with 3 will give me 81. So therefore, our option is going to be on part D. Okay, so I hope it is very clear. Yes. Okay, so let's do the next question. So question number 8. So HCF of 144 and 98. So we need to determine the HCF of 144 and 198. So first we have to determine the prime factors of 144. So what are the prime factors of 144? So 144 divided by 2 will give me 72. And then 72 divided by 2 will give you 36. And then again, 36 divided by 2 will give you 18. And then 18 divided by 2 will give you 9. And then 3, 3, 1. So our prime factors for 144, which is equivalent to 2 to the power of how many times? 1, 2, 3, 4. Okay, so 2 to the power of 4 multiplied with 3 to the power of 2. And then next, our prime factor for 198. So our prime factor for 198. So 198 divided by 2, which will be 99. So if I'll take the 99 divided with 3 will give me 33. And 3 again divided with 3 will give me 11. And then 11 is the prime number. So I can write this 198. The prime factor for 198 is 2 multiplied with 3 to the power of 2 multiplied with 11. So we have to determine the HCF. So basically HCF is the least power of the common factor. Basically first we have to see what is the common between them. So is there a 2 common between them? Yes, there is a 2 common between both the number, and then we have to see the least power of these two common numbers. What is the least power of these two common numbers? That will be 2 to the power of 1. And then again, we have to see there is a common between 3 and 3. So what is the least power between them is 2. So therefore, our HCF will become 2 to the. So for LCM, we have to see the highest power. For HCF, we have to see the least power. So 2 to the power of 1, 3 to the power of 2. So what is 2 to the power of 1 is 2, and 3 to the power of 2, which is 3 times 3, which is 9. Don't write 6. Okay. So 2 to the power 2, 9, 2 times 9 is 18. So therefore, our option will become 18 is the right answer. So sometimes, in a hurry, we'll write 3 twos are 6 and 2. So that will be 12. So there is an option 12 also. You'll do the mistake. Okay. Don't do that. 3 square is 9 basically. You have to do that as 2 multiplied with 9, which is 18. Yes, because my lot of my students have done that mistake. So from that experience, I'm telling you. Yes. So question number 9, the decimal expansion of the rational number is 14857 and then 1250. So we have to terminate after. So we have to write down. So this question is similarly that we have done in the past. So first we'll write down 14587 divided by 1250. So we have to determine the prime factors of 1250. So what is the prime factors of 1250 is divided by 2 will give you 625, and then 625 divided with 5, which will give me 125. So 125 divided by 5 will give me 25, and then 5 times 5 times 5, 1. So that will give me the denominator 14587. So I have to see the prime factorization of this. So 2 to the power of 1 multiplied with 5 to the power of 1, 2, 3, 4. Okay, so 5 to the power of 4. So here at the denominator, I have to see the maximum power. So which is the maximum power? That will be 4 is the highest power, right? So for this highest power, which will be the terminating decimal. So our right answer will be option 4, which will be 4 is the correct option. So 4 decimal places. So option D is the right answer for this particular question. So next question is, so if two positive integers a and b written as a is equal to x to the power of 3 y squared and b is equal to x cubed x y cubed, where x and y are the prime numbers, then HCF of these two numbers is. So basically, let us take our a value. What is our a is equivalent to? A is equivalent to x to the power of 3 y squared, and then our b is x y cubed. So basically, so what is our HCF? So we know HCF is the least power and the common between them. So first we have to determine the common. So what is the common between these two variables, which is x is the variable common between these two. So which is having the least power, x to the power of 1. Again, we have another common letter, which is y. So what is the least power of y, which is y squared. So then our answer would be xy squared. So therefore, we have to see which is our option. So B, which is having xy squared. So therefore, our correct option is option B for this question. Xy square is our answer. So next question. So find the HCF of the number given below. So there is something error. So we have to write only the number, which is k, 2k, 3k, 4k, and 5k. So if there was no k, then we got our HCF would be 1, 2, 3, 4, 5. So these are the prime numbers. Only one would be our answer. But in this case, we have a k is common. K is common. So therefore, we can say every multiple of, okay, so every term is a multiple of k, right? So since 1, 2, 3, 4, 5 share other common number factor, right? So therefore, our greatest common divisor will be k. So we can write our answer is k. Okay. So in simple words, we can say that so every term is a multiple of k. So every term is a multiple of k, is a multiple of k, and since 1, 2, 3, 4, 5 share no common factors, therefore the greatest common divisor is k. So this is how what the sentence you have to write it for this particular question. Next question. So find the missing number A, B, C. So we can say that here 18018. So if we divide it with a 2, so I'll get, if I'll take the prime factor, right? So if I'll divide with 2, so what will I get? 18018 divided by 2, I'll get 9009. And then, so 9009, there is an odd number at the end. So I'll divide with 3. What will I get? 3003. So, and then again, I'll take the least prime number, which is 3. Again, I'll divide with 3. I'll get 1001. Again, if I'll try to divide with 3, so we'll get some decimal. So we have to look for the next prime number, which is 5. So 5 cannot divide 1001. And then we have to next look at the next prime number, which is 7. So 7, which is divided with 143. So and then again, 7 divided by 143. So this number I got here, the A value is 3, and then B value I got it 7. So if there is two empty places over here, so these two empty places will be a prime number. So the prime number will be, next prime number will be 11 and 13. So we can write here 11 and 13. So 13 times 1 is 13. So that is how we, so this must be what, if whenever there is a two empty spots is given, so that two empty spot will be what, a prime, which is the next two prime numbers. Okay. So next question. So find the smallest natural number by which 1200 should be multiplied so that the square root of product is a rational number. So we have so 1200, right? So what are the prime factors of 1200? So let us do the prime factors of 1200. So 1200 divided by 2 will give me 600. And then 600 divided by 2 will be 300. And then again, if we divide it, will be 150. Again, if we divide it, that will be 75. So then again, I'll divide with 3. 75 divided with 3 will give 25. And then 5 times 5. And then 5 times 1. So therefore, my final answer, what I'm going to get, the prime factorization of 1200, which is 2 to the power of 1, 2, 3, 4. Okay, so 2 to the power of 4 multiplied with 3 multiplied with 5 to the power of 2. So we got, this is a prime factorization. So we have to see here, find the unpaired factor. So what is the unpaired factor? So the unpaired factor, the factor which has 3 as the odd power. So we have to determine the odd power. So 3 have the odd power. 3 have the odd power. So to make it even power, that's what the required question, right? So to make it even power, multiply with 3. So if I'll multiply with 3, this will become the odd, now the odd power. So 2 to the power of 3 squared multiplied with 5 squared. So now everything is even power. So therefore, the smallest natural number by which 1200 should be multiplied, that so that it is a square root of the product is a rational number. So if you do all this square root, right? So what is 2 times 4 is 8. 8 times 4 is 16, right? So 8 times 2 is 16. So 4 times 2 times 2, if I'll take it. So 4 times 2 is 8. 8 times 2 is 16. So 16 is, what is 16? So 16 square root of 16, which is 4. So therefore, our power of the square root will be what? 16. So therefore, if we multiply, 3 is basically, it was odd number. So now we have to make it even. And then, so therefore, our answer is what for this particular question is 3 is the a rational product that should be multiplied. Okay, so find the smallest natural number. That smallest natural number will be 3. I hope this question is clear. So next question. So write the smallest number which is divisible by 306 and 657. So now first we have to determine the LCM between 306 and we need to determine the LCM between these two. So what will be the LCM of 306 and 657? So the LCM of 306, to half of that will be 153. And then that will be, again, if I'll divide 153 with 3, I'll get 51. And then if I'll divide 51 with 3, I'll get 17. So 17. So I'll get the factorization of 306 will be 2 multiplied with 3 multiplied with 3 multiplied with 17. So this will be my prime factorization, 2 multiplied with 3 squared multiplied with 17. And then next we have our number, which is 657. So 657, our prime factorization would be 657. So 3 and then 219. If I divide with 3, that will be 219, and again 219, that will be divided with 73, so 73. So my prime factorization of this will be 3 squared, and that will be multiplied with 73. So we have to find the smallest number which is divisible by both 306 and 507. So if we determine the HCF, right? So what will be our HCF? So HCF will be 3 to the power of 2, right? So that will be that is the only common thing. So HCF is 6. So I got HCF 3 squared, right? Basically it is 3 square is HCF, which is 9, right? Not 6. So LCM, we know that the relation between LCM and HCF, which is equivalent to the product of their numbers. So 306 and 657. So we know we have to determine the LCM. That will be the smallest number because least common multiple, which is the smallest number. So my HCF will be 9, and then which is equal to 306 multiplied with 657. So therefore our LCM, which is equal to 306 multiplied with 657 divided by 9. So if I'll divide 306 with 9, 306 divided by 9, so I'll get 34. So 34 multiplied with 657 will give me 22,338. So our next question, given that root 2 is irrational and prove that 5 plus root 3 is a rational number. So first we have to assume that 5 plus 3 root 2 is a rational number. So we have to take the contrary, that irrational, right? So irrational number. And then we have to equate that 5 plus 3 root 2, which is equivalent to a by b, where a and b are co-prime. So which means they will have only factor, which is no factor other than 1, right? So that is the basically meaning of prime factors. And we take now 3 root 2, which is equivalent to a by b minus 5. And then root 2 is equivalent to, I'll bring down this 3 at the denominator. That will be a minus 5 by, okay, 5b by 3b. So we can see that if I bring this 3 over here, this will get multiplied with 3, and then this 5 will get multiplied. Yeah, so we can see that irrational is never equivalent to the rational number. So therefore, we can say that the root 2 is irrational. Root 2 is irrational, and where the p a minus 5b and divided by 3 is a rational. So therefore, we can say that 5 plus 3 root 2 must be irrational, because this is wrong, right? So it can never be equal, right? So irrational is can never be equivalent to rational. So therefore, our assumption is what? Wrong. So therefore, we have to write that 5 plus root 2 must be irrational in this case. Yep. Next question. Question number 16. So can two numbers have 15 as their HCF and their LCM is 175? So first rule number. So HCF must be perfectly divided by LCM. So if we wanted to check whether two numbers have 15 as their HCF and their LCM is 175, so we can divide it. So 175 divided by 15 will give me 11.67. So which is basically not an integer. So if it is not an integer, so then we can say that, so no, because so this two numbers Have 15 cannot be their HCF. No, because HCF does not, we can say, does not completely, completely divide LCM. Okay, so I hope this is the answer for this question. So I hope you have understood. So our next question, find HCF and LCM of 16 and 36 by prime factorization and check the verification method. So we have to determine the prime factorization of 16. So 16 to 2, 4, 2, 2, 2, 1. So what is the prime factorization of 16, which is 2 to the power of 4? So what is the prime factorization of 36? If I'll take 2, which is 18, 2, 9, 3, 3, 3, 1. So the prime factorization of 36 will be 2 to the power of 2 and 3 to the power of 2. So basically, what is our HCF? First, we can determine LCM. So we have to see the highest power of these two. That will be 2 to the power of 4 and 3 to the power of 2. So 2 to the power of 4 multiplied with 3 to the power of 2 will be equivalent to 144. So that will be 16 multiplied with 9, which is 144. So our HCF will be the least power among the common numbers. So we have to see the common number between them is 2. 2 is the only common. So what is the least power of that is 2 to the power of 2, which is 4. So 4 is our HCF. So now we got the HCF and LCM. So now we know that the relation between HCF and LCM, which is LCM multiplied with HCF, will give you multiplied with first number and second number, right? So this is the relation. So what is our HCF? 144 multiplied with 4, which is equivalent to what is our first number, which is they have given 16 and 36. So if I'll multiply 144 with 4, I'll get 576. And then if I'll multiply 16 multiplied with 36, I'll get 576. Yes. So these numbers are prime factorization of 16 and 36 have their LCM, and then it is verified that 576 and equivalent to 576. So I hope you have got it. Yeah. So question number 18 says that the find the HCF and LCM of, okay, so I hope we have done that question already. So next question, which is question number 19. So explain whether 3 multiplied with 12 multiplied with 101 plus 4 is a prime number or a composite number. So we can write down that numbers 3 multiplied with 101 plus 4 if I'll write it. So if I'll take down the common between them, which is 4, 3 multiplied with 3 times 4 times 3 multiplied with 101 plus 1. So we got here, since it has a factor other than 1, we can see there is a factor. So we can write down the reason. So since it has factors other than 1 and itself, 1 and itself, so it is a composite number. It is a composite number. Okay, so and then the final and most last important question, which is write a rational number between root 2 and root 3. So 5, I'll write the value of root 2, which is 1.414, which is standard, right? So and then if I'll take the root 3 value, which is 1.732. So and then terminating, any terminating, any terminating decimal, any terminating decimal in between works, such as we can say 1.5 is a terminating decimal. So we can say that, so 1.5 is the rational number between root 2 and root 3 because it has terminating decimal. So which means it stops 1.5, it is stopping. So 1.45, that which are not terminating decimal. So that's it. The most 20 important questions we have solved in this particular lesson. So if you're looking for an online class, you can contact me on this WhatsApp number, which is, I'll write it down. So +97 +91 Okay, 97381474490. So you can only WhatsApp me on this number for if you're looking for one-on-one online lessons. So hope you have understood all the questions. If you have any questions or doubts, you can WhatsApp me on this number. Do subscribe and hit the like button. Thank you. Hope you have understood.